This is the last section of Chapter 7 that you guys are going to work on. And this will be on the test, so the stuff we did first, the 7175 stuff, which was the solving trig equations, then the trig IDs that you just quizzed on, and now the sum and difference. So you're going to need your sheet with the identities, and we'll just put the new formulas on the bottom or the back, and then you probably also want your unit circle that has radians and degrees. So we're going to find sine and cosine of an angle that's not on the unit circle using angles that are on the unit circle. So just as a reminder, like on the unit circle, you find your angle, and then to find sine, it's the y value, for example, or pi over 2. We know the point is over 0 up 1, so the sine of pi over 2 is 1. So just a reminder, we use those x and y values. Now when we come to, for example, cosine of 50, okay, we can't find 15. I think I just said 50, but we can't find 15 on the unit circle. And if you took in your calculator and took the cosine of 45 and subtracted the cosine of 30, you could get an answer. And that would be very different, a different answer, than if you did this. Okay? And you can compare them right now if you would like, but these two things are not equal to each other. And so we can't just take like cosine of 45 and subtract cosine of 30 and hope for cosine 15. We have to use these sum and difference formulas. So if you find two angles that add together, that's a sum formula. And if you find two angles that subtract, that's a difference formula. And I thought that I put them all on my slides, but I'm starting to wonder if I did or did not put one on this one. But here is just the cosine formula. And there's some Greek letters that they use. I don't actually want black highlighter. And they're alpha and beta. These are just Greek letters. And they're just standing for angles. So alpha and beta. Then you'll see the alpha and beta here and alpha and beta here. And that means if you take, for example, 45 minus 30, because 15 is 45 minus 30, this is your alpha and this is your beta. So when I take 45 minus 30, I get 15, and I want to know the cosine of 15. So you are going to follow this formula, but you also need your unit circle. So we'll have cosine of alpha, which is our 45-degree angle, times the cosine of beta, which is our 30-degree angle. And then there's a plus in the cosine formula. So sine of 45, and then sine of our beta. Oops, I wrote beta in there last time instead of 30. I'll do it again this time. 30 for both of these. So here's where your unit circle comes in handy. Now I know cosine 45, my 45s are this, so I'm going to put this here for both of them. And then cosine of 30. So this one's square root of 3 over 2, comma 1/2. Cosine of 30 is square root of 3 over 2. And sine of 30 then is 1/2, and then there's a plus sign in here. So as we multiply fractions, we multiply it across the top, and since the 2 and the 3 here are both under the square root, we can call that square root of 6, and 2 times 2 is 4. And then square root of 2 times 1 is square root of 2 over 4. And we can combine these because they have a common denominator, but we cannot combine the square root of 6 and the square root of 2 because they don't have a like term in them. Okay, so we can't do anything with them. You will find that a lot of the answers look really similar to this. They have square roots of 6s, square roots of 2s, divided by 4. You'll find a lot of them like that. And that's okay, and a lot of them will look the same. But just like a lot of our answers are square root of 3 over 2 and 1/2 and square root of 2 over 2 on the unit circle, there will be repeats. So this is the final answer for what the cosine of 15 is using a sum and difference formula. So I put one on here for you to try, so I would love for you to pause your video and you work on it, and then I'll work on it as well, and then you can check your work with mine. So this would actually be sine of 75, but I didn't put that in there. So this is sine, and I'm going to use this plus formula. So sine of 45 is 30 equals sine 45 times the cosine of 30 plus the cosine of 45 and the sine of 30. Now, if I remember from last time we did this on the last slide, these were my answers here. And like I said, you're going to come up with a lot of similar ones, because when we do this, I get, actually, it's the exact same answer. Oops, this should be a 4. And this should be a square root of 2. Square root of 2 all over 4. Okay, so just like applying that formula for sine and or cosine, just being able to match up which one and then follow the formula. I didn't want you guys to think that it was all easy ones like 15 and 75. So 285 could be more difficult. So you're going to actually have to kind of like think about, okay, what numbers could I use? I don't think 270 would work because that'd be 270 and 15. What else could you use? 270, how about, we got 180. 180 plus 155, right? 155 is on our unit circle, I believe. So you should be kind of like checking your unit circle and coming up with two. Other people might find subtraction. So if you can find two things that subtract to make this, like 300, that might not work. 330 minus 285. Yeah, so you could do 330 minus 45. Those are both on your unit circle. Someone else might find one to add up. And then like when you do radians, the hard part about radians is that none of them are in twelfths, and I almost always give you twelfths. So if I, like this is pi over 6, right? And pi over 4 and pi over 3. I hope that you see that these are all twelfths. So this would be 4 pi over 12, and this would be 3 pi over 12, and this would be 2 pi over 12. And hopefully you see right here, you could add 3 pi over 12 plus 2 pi over 12. Once you know that, then you can really actually write it out like cosine of 5 pi over 12 is equal to the cosine of pi over 4 plus pi over 6, just so it's easier on your unit circle, but you need to change them all to twelfths first before you do this. So I'm going to do a tangent example for you, and when we do tangent, it will not be on your test. But we're going to do an activity, and tangent's going to be on there, so I want you guys to see it once before I give you an activity. So taking notes on this part will be helpful. So 15, I'm going to use 45 minus 30. So the tangent of 45 minus 30. And this is the tangent minus formula, which says I take the tangent of 45 minus the tangent of 30, all divided by 1 plus tangent 45, tangent 30. Okay? So first thing you should do is check out your unit circle. So I need 30, which is this, and 45. And the tangent of 45 is 1, so that makes our life easier for some of this. So 1 minus, and then 1 plus 1 times. Now I got to come up with tangent of 30. So tangent 30 will be 1/2 times 2 over the square root of 3. That cancels, so I get 1 over the square root of 3, and you know we can't leave it like that. So square root of 3 over 3. So 1 minus the square root of 3 over 3 plus 1 times the square root of 3 over 3. Okay, this looks really frightening, and it is slightly frightening. But the next thing that we need to do is to kind of rationalize the denominator here so we can deal with it. And to rationalize the denominator, we're going to multiply by, this is going to sound weird, this word is called the conjugate. And when we multiply by the conjugate, it's going to get rid of this piece down here that's square root of 3 over 3 without kind of creating middle terms, because we need to FOIL. Okay, we need to take 1 times 1, and we're all in the denominator is 1. We're going to get minus the square root of 3 over 3 plus the square root of 3 over 3, and then minus, and I'll write this out for us so that we know what's happening. And that's like a squared term, and that's going to get rid of the square roots. These are canceling out. I hope you see that. So what we have in the denominator now is 1 minus this square root of 3 over 3 times square root of 3 over 3. And what does that equal out to? I was hoping that I could just erase this and write it here to simplify. Okay, so square root of 3 over 3. So square root of 3 times the square root of 3 is 3, and 3 times 3 is 9. So if we move this, I get 1/3. 1 minus 1/3. Okay, that is my denominator. That's it, not any of the rest of the stuff. 1 minus 1/3. If I do that to the bottom, then I have to do that to the top. Okay, so I have to multiply the top. And we will have here 1 minus the square root of 3 over 3 minus the square root of 3 over 3 plus square root of 3, this thing again. Okay, so the middle term becomes minus 2 square roots of 3 over 3. Just trying to save some space here. Let's see. 2 square roots of 3 over 3. And then again at the end, if I erase that, we're going to get 1/3 here again. Okay. That's what we have. So now we have this weird looking thing. It looks weird again. 1 minus the square root of, 1 minus 2 square roots of 3 over 3 plus 1/3 all over 1 minus 1/3. And we're still going to keep going a little bit here. So if I combine on the bottom 1 minus 1/3, I do have 2/3 in my denominator. And I have 1 plus 1/3, so that's 4/3, minus 2 square roots of 3 over 3. So hopefully you notice that I can add these now together. So I'm going to do that and get 4 minus 2 square roots of 3 over 3, all divided by 2/3. Again, super funky looking, super scary, but good things start to happen now because I can take this minus 2 square roots of 3 over 3 and multiply by the reciprocal of 3 over 2. And look at 3's cancel out. So now I've got 4 minus 2 square roots of 3 over 2. And then I can factor a 2 out of all of these terms. That turns to 2, so I get 2 minus the square root of 3. That is the answer. That's our final answer. I know that this was really difficult. Again, I'm not going to expect you to do this on the test, but I'm hoping that when we do an activity this week that you will be able to kind of work your way through these tangents and get an answer like this so that you really feel comfortable with the sine and cosine. If you can do tangent, sine and cosine are easy.